On September 26, 1959, at 6:13 p.m. local time, the storm surge height at the mouth of Ise Bay reached 3.89 meters above mean sea level. The coastal embankments protecting Nagoya's reclaimed industrial districts had been constructed to a maximum height of 3.5 meters. For the next 11 hours, the Pacific Ocean moved inland at a rate faster than the municipal drainage systems could respond. By 1959, the city of Nagoya had expanded its coastline through extensive land reclamation projects spanning 31 square kilometers of filled tidal flats. The protective dikes surrounding these districts consisted of compacted earth reinforced with timber piling, constructed between 1920 and 1955. Design standards called for embankment heights of 2.7 to 3.5 meters above mean high water, based on the highest recorded storm surge in regional history, the 1953 event, which peaked at 2.1 meters. The reclaimed zones housed lumber storage facilities, textile factories, and residential blocks built at elevations ranging from 0.5 to 1.2 meters below sea level. Gravity drainage and electric pumps maintained livable conditions. No storm of record had produced sustained water levels exceeding the embankment crown. Typhoon Vera formed in the western Pacific on September 20, 1959, and underwent rapid intensification between September 23 and September 25. Maximum sustained winds reached 160 miles per hour with a central pressure of 895 millibars, categorizing it as a super typhoon. The storm tracked northwest at 15 knots, decelerating as it approached the Japanese archipelago. Landfall occurred at the Key Peninsula at 6 p.m. on September 26, coinciding precisely with the astronomical high tide cycle for Ise Bay. The Japan Meteorological Agency recorded wind speeds of 131 miles per hour at Cape Shionomisaki. The forward motion of the typhoon combined with the high tide to generate a storm surge forecast at 2.5 meters. The actual surge exceeded all predictions. At 6:13 p.m., tide gauges at Nagoya port registered water levels at 3.89 meters above datum. The embankment system began overtopping along a 12-kilometer front. Initial flow rates across the dike crests ranged from 15 to 40 cubic meters per second per linear meter. Within 18 minutes, erosion channels formed on the landward slopes of the earthen barriers. The compacted fill could not withstand the hydraulic shear. By 6:45 p.m., 6 separate breaches had opened, each expanding at rates between 8 and 15 meters per hour. Water entered the reclaimed districts as a sustained flow rather than a single wave. The drainage pumps, designed for rainfall runoff at 12 cubic meters per minute, faced inflow rates 200 times greater. The systems were mechanically incapable of counteracting the surge. Wind speeds over Nagoya sustained at 105 miles per hour for 4 consecutive hours. The combination of continuous wind stress and elevated water levels prevented any reduction in the storm surge height until after 11 p.m. The reclaimed land basins, now functioning as reservoirs, continued to fill. Electrical substations supplying the municipal drainage pumps were inundated by 7:30 p.m., eliminating all mechanical evacuation of water. The tidal cycle did not reverse until 12:47 a.m. on September 27th, more than 6 hours after the initial breach. During this period, the reclaimed districts received an estimated 340 million cubic meters of seawater. The depth in the lowest zones reached 4.2 meters. No active pumping capacity remained operational. The structural failure of the dike system transitioned 31 square kilometers of urban infrastructure into submerged terrain. Buildings constructed on reclaimed land were not engineered for hydrostatic loading. Foundations designed for compression experienced sudden buoyant uplift in lateral pressure. Wooden residential structures began floating free from their moorings by 8 p.m. Concrete industrial buildings experienced wall failures as the differential pressure between interior air pockets and exterior water columns exceeded design thresholds. The Minami ward reported building collapse rates of 34% within the first 3 hours of inundation. The reclaimed land, geologically unstable, experienced liquefaction under the combined loading of water weight and seismic vibration from collapsing structures.
The entire district ceased to function as a platform for human activity.
Nagoya's port and industrial zones maintained 847 timber storage ponds containing an estimated 450,000 cubic meters of raw logs awaiting processing. These containment systems, designed to hold buoyant material in standing water, failed when the storm surge introduced current velocities exceeding 2.5 meters per second. Restraining booms and fences disintegrated. By 7:15 p.m., thousands of tons of logs were in uncontrolled motion, driven by wind and water. Individual logs weighing between 800 and 3,000 kilograms and measuring 8 to 15 meters in length acted as battering rams against structures in their path. The Atsuta district recorded impacts that penetrated reinforced concrete walls up to 40 centimeters thick. Buildings that survived initial flooding were systematically destroyed by repeated timber strikes. The logs created secondary debris fields that blocked all remaining evacuation routes. The Tokaido Main Line, the primary railway corridor connecting Tokyo and Osaka, crossed the Ise Bay flood zone on elevated embankments and bridge structures. By 9 p.m. on September 26, water levels exceeded the railbed elevation at 14 distinct locations. The Nagoya Station District experienced inundation depths of 2.8 meters, submerging all switching equipment and signal systems. 3 bridges spanning tidal channels experienced pier scour and lateral displacement, rendering the tracks geometrically impassable. Nagoya Port, handling 40% of the region's maritime cargo, saw the complete destruction of 22 cargo cranes, the sinking of 19 vessels at dock, and the collapse of 8 kilometers of wharf structure. All container handling ceased. The regional transportation grid, both rail and maritime, went offline simultaneously. Recovery operations beginning on September 28 confronted a flooded urban zone holding 340 million cubic meters of salt water mixed with industrial chemicals, sewage, and suspended sediment. The disabled municipal pumps required complete rebuilding. Temporary pumping capacity, assembled from regional resources, achieved a maximum evacuation rate of 1.8 million cubic meters per day. Complete drainage required 189 days. Salt contamination rendered agricultural land in the reclaimed zones unusable for 3 growing seasons. The removal of timber debris from urban streets and waterways required 14,000 worker hours per square kilometer. Demolition of structurally compromised buildings proceeded at a rate of 47 structures per day. The timeline for restoring basic municipal services extended 19 months from the initial event.
The total inundation footprint covered 31.5 square kilometers of Nagoya and surrounding municipalities. Maximum recorded water depth in residential areas reached 4.7 meters in the Minami Reclamation District. The official building damage count registered 150,129 structures completely destroyed and an additional 210,000 structures sustaining major damage. The Japan Meteorological Agency classified the storm surge as the most severe on record for the region. The fatality count reached 5,098, with an additional 1,533 individuals listed as missing and presumed deceased. Economic losses were calculated at 600 billion yen in 1959 currency. The storm rendered 1.2 million people temporarily displaced. The reclaimed land districts required total reconstruction. Industrial production in the Nagoya zone did not return to pre-storm capacity until 1964. The Japanese government enacted the Disaster Countermeasures Basic Act in November 1961, establishing the first comprehensive national framework for emergency management and infrastructure resilience standards. The Ise Bay coastal defense system underwent complete redesign. New seawalls were constructed to a minimum height of 6.5 meters above mean sea level, with reinforced concrete replacing earthen embankments along 153 kilometers of coastline. Subsurface drainage systems were installed with backup power supplies isolated above the projected maximum surge line. Timber storage facilities were relocated inland or equipped with reinforced containment systems rated for Category 5 typhoon wind loads. The reconstruction required 11 years and consumed 18% of the national public works budget. The Ise Bay barrier system, completed in 1972, remains the design standard for Japanese coastal megaprojects.